Hi everybody, this is Mr. Bozade again. I am right now going to do a couple example problems for you on graphs. So that's LT4, the graphing target. Before you start to follow me on this, make sure you've printed out the target sheet that goes along with this. I'm going to have this in front of me and I'm going to use it to reference as I'm going through these problems. So remember, this target sheet is really helpful because it talks about position versus time graphs and what we know about them if we're going at constant velocity versus changing velocity, as well as velocity time graphs and what we know about kind of the rules for them if we're going at a constant velocity as compared to a changing velocity. So make sure you have that printed out in front of you while we're going through this. Okay, here's one of the two problems we're going to look at. So given the following position versus time graph, A, describe an initial condition of motion for the object, initial position or initial velocity, and use parts of the graph vocabulary to explain how the graph shows that. Well, you know, the most important thing when you are answering LT4 graph questions is you always need to talk about two things in your response. Number one, talk about what the graph, what the object's doing, and number two, talk about how the graph shows you that, okay? If it helps you, you could even, like, every time you do one of these, like, number it 1 and 2. So first I'm going to talk about the object. Well, because we see that the y-intercept is in the positive quadrant, or it's a positive y-intercept, we know that it's going to start with an initial position that's positive. So the object has, actually we'll say object, let's go ahead and say that. So the object, do we know what the object is? No, we don't. So the object has a positive initial position because the graph has a positive y-intercept. Okay, sorry about that. I ran out of space a little bit. But you can see I did the two things. First, I talked about what the object's doing, and then I talked about the graph. You've got to do that every time. Another real important thing I want to highlight here is I didn't say the object has a positive initial position, or sorry, I didn't say the object has a positive initial condition. You know, see here it says describe the initial condition. But you're supposed to choose, is it initial position or is it initial velocity? And in this case, because this graph is a position graph, we know it's the y-intercept is telling us about the initial position. In a moment, I'm going to do this guy down here, and this is a velocity graph. So then we're going to be talking about initial velocity. But right now we're looking at a position graph. Okay. Then now I'm on to part B. Describe the direction of the object. The object is moving, and use parts of the graph vocabulary to explain how the graph shows you that. So again, we're going to talk about the object, and we're going to talk about how the graph shows us. So the object, what we know is that we can look at the slope, and we can see, we can do kind of our pen trick and hold our pen up to it and see that our pen goes like this, and like that, and like that. And notice that the pen points in the positive direction the whole time. So the slope is positive the whole time, which means, you know, by positive I mean it's pointing upwards, kind of, it's got a positive slope. So since the slope is positive, that means the object's moving in the positive direction. So here we go. Let's write that out. So what we're going to say is the object is moving in the positive direction because the graph has a positive slope. And once again, I want to point out to you that this is me first talking about the object, then talking about the graph. Now, you could do it the other way around, but you've got to do both things every time, right? You could have said the graph has a positive slope. This means the object is moving in the positive direction. You know, you could say them in either order, but you've got to do both things. Finally, describe what we're going to do C here. Describe what is happening to the speed. Is it 0? Is it constant speed? Is it increasing? Is it decreasing during the time shown? Well, again, because we did our little pen trick here where we held our pen up and we saw our pen looked like this and then like that and like that, what we noticed is that the angle of our pen, the steepness of our pen, the steepness of the slope got shallower as time went on. So when the slope gets shallower, that means the velocity is decreasing. It's slowing down, and so all we need to do is put that into words. Okay, so what we're going to say is the object is slowing down because the slope of the graph is getting shallower. It's getting shallower. Okay, and so again, we did the two important things. We talked about the object, and we talked about the graph. Again, you could have done it in the other order. You could have said, because the slope of the graph is getting shallower, the object is slowing down. Okay, but you've got to do both those things. And now let's take a look at a velocity graph. So this says, describe the initial condition of motion for the object. Okay, well, we know that we're going to talk about the y-intercept, and this time we're going to be talking about the initial velocity because it's a velocity graph. So we're going to say the initial velocity is, let's see, is it positive or negative? It's negative. See, it starts down there. Is negative because the y-intercept is negative. There we go. Again, I can't emphasize this enough. I first talked about the object, and then I talked about the graph, okay? And I'm using my key language about the graph, right? I'm talking about the y-intercept, right? Kind of like up here, I use some really important key language, right? Like I talked about the slope, and I talked about the steepness of the slope, or I talked about the slope, and I talked about the positive or negativeness of the slope, right? So you really want to, when you talk about the graph, make sure you're using like our key and important vocabulary, right? And that's why in our questions, we're saying use parts of the graph vocabulary because there's very specific vocabulary we're looking for you to use. All right, part B says, describe the direction the object is moving. Okay, well, what I see is that the line is in the negative quadrant, right? It's down here is where the line is located, down below the x-axis in the negative quadrant. If you think about it, I like to put numbers on the axis. Like maybe this is negative 3 meters per second, and then like here's negative 2 meters per second, negative 1, and then 0. The key is to remember one real important thing on these velocity graphs is to remember that the x-axis is 0 meters per second. So if the line ever touches the x-axis, that means the object is not moving. The object's at rest, okay? So that's important to remember. Anyway, but right now we see that this line is completely negative values. It's completely like negative 3, negative 2, negative 1, which means since it's in the negative quadrant, that means the object's moving in the negative direction. Okay, so let's write that out. So we'll say the object is moving in the negative direction because the line is in the negative quadrant. The line is in the negative quadrant. Boom. There we go. And again, notice that I talked about the object and then I talked about the graph, the line. And I used key graph vocabulary like negative quadrant. Okay. Last one, describe what is happening to the speed. Is the speed zero? Is it constant? Is it increasing? Is it decreasing? Well, one of the things that we know, one of the kind of like rules, if you will, about velocity graphs is that if the line is getting closer to the x-axis or the time axis, it means that we are slowing down. And just like I reminded you a moment ago, that makes sense because the time axis corresponds to a velocity value of zero, meaning you're at rest. So if your speed is getting closer to zero, we know you're surely slowing down. So now we just have to write that out. So we'll say the object is slowing down. The object is slowing down. Because the line is getting closer to the x-axis. Okay, final time to show you. Once again, I talked about the object and then I talked about the graph. And I used the key graph vocabulary, like closer to the x-axis. There you go. I hope these examples help you a lot for next week's summative. I hope they help you better understand target LT4. And I will see you later.